Right, so today we'll be talking about the topic about managing process in Linux or Unix. Unix and Linux actually it's a different things. It's different operating system, but they are behaving in the same way. Okay, so the main difference between them, between Unix and non-Unix, is the certification. So if you build an operating system and then you want to call that operating system to be called as Unix, you have to go to Open Group. Open Group is an organization that runs that runs the a specification of Unix. Okay, so you go to Open Group and then please certify. Please check my operating system here, and then certify it as Unix. Okay, because Unix is a brand. Okay. So that you cannot just make an operating system and call it Unix. No, it seems like, okay, I made an operating system, I call it Mac OS. Okay. No, it's not. It's a brand. Okay. Uh, yeah. So and then they protect the brand, and Unix is no exclusion. So that if you want to call your operating system Unix, you have to go to Open Group. Well, we don't talk about the Open Group here tonight, right? We talk about the managing process inside them. So let's get started. Okay, this is the agenda. First, we'll be talking about the Unix process. So what is Unix process? Oh, perhaps I can share because we'll be doing a lot on practice, so that perhaps I can share you directly the access to the live service. Okay, please wait a moment. I will share. Forgot the. Okay, I need to open the notes here to access to open access to the live practice pass server. Okay, wait a moment. Okay, I've shared the access to the live server, so hopefully you can access them. Okay, and then log in, and then we can practice them together. All right. Okay, I'm in. Yes. Okay. Right. Okay, put them here. Okay, and then we can start. Okay, so it's just only me who already logged into the live system. So if you are new and then you're confused how to access, please download an SSH terminal. Okay. Okay, let me share the whole screen. Okay, so please share. Please download the what is it? Yeah, party to connect. Yes. And then we can. I can see one user only log in here. Okay, that's good. So yeah, we can start. We can continue the show. Right. So I'll be focusing on the. I mean, better just do both of them. Okay, just open things like this. Okay, guys. So please log in. Okay, please log into the live practice server. Okay, and then we can do live practice directly from the beginning, because I think better if we do the webinar here with the live practice. Okay. Okay. So agenda will be Unix process. Okay. So we'll be talking about what is process, okay, and then process management. Background, foreground process, I think it's already made here. And then after that, we can send some signal to processes, okay? Yeah, if you have any questions, and then you can write those questions in the group chat. And yeah. Access denied when I type password. Well, so perhaps you type the password incorrectly. Okay, so you have to change the X into a number. Okay. Right, so hopefully that can answer. Okay, I can see many people already log in to the server, which is good. Okay, so I don't know what's going on with your computer there. Yeah, one more thing. If you log in several times and then you log in several times but failed, and the system will block your IP address, okay? Right, okay, I think that's enough. Okay, more and more people are okay connected now. Okay, thank you very much. Okay, let's continue. Yeah, those are the agenda of our webinar today. Okay, let's continue. Introduction. Okay, for those who are new. Okay, so this is introduction about our organization. So we are GLC, Garda Lintas Cakrawala. This is our website. We are based in Bandung, Indonesia. So our areas are training and IT consulting. We are certified partner for MicroTik, Ubiquiti, Linux Foundation. Our product is GLC Radius Manager, and then we run regular event like this webinar every Thursday night. My name is Achmad. I'm based in Bandung, Linux user since 1999. MicroTik user since 2007, Ubiquiti certified trainer, website contributor, and if you have LinkedIn, we can connect to LinkedIn. Okay. Past experience, 2020, we had project in Malaysia and Congo related to IT, IoT integration, network automation. In last year, 2019, we have also a project in Congo, built wireless ISP. And then before in Malaysia, I think we have lots of things to do in Malaysia. Yeah, mainly related to network and application development, especially related to ISP. Okay. So we set up a full solution with ISP, started from what is it? From a technical configuration, physical configuration, and then build this software to manage the operation. Okay, next about the webinar itself. We started the webinar since 2010. Yeah, in the new year. Yeah, actually I had nowhere to go during the New Year's. So because last night we were in the firework festival watching the New Year, and then in the next morning we had our first webinar. Our first topic was Solaris operating system. It's Unix as well. So my background mainly are Linux, Unix, and networking and programming. Okay, so thank you very much for introducing yourself here. I can see, okay, some of you are familiar name. Thank you very much for coming again. And then I can see some of you are not from Indonesia, from overseas, right? Okay, so if you don't mind, you can introduce yourself here. Yeah, just tell me where you're from and then what you're doing, and hopefully you can get most of the webinar here. Okay, so, okay, thank you very much for introducing yourself. Somebody from Africa, Ghana. Okay, I was in Africa, in Congo and Tanzania and Senegal, yeah. Ghana is a little bit west in Africa, if I'm not mistaken, if I can recall my memory correctly. Yes, right, in West Africa, yes. I know when I was in Senegal, we were supporting an operating system, not operating system, an operator, sorry, operator for a migration in Senegal. Okay. Yeah, it was a nice experience being in Africa. Okay, so let's continue with the Unix process. So process is an instance or execution of a program. Okay, so when you execute something, you're creating an instance, or something like that. So when you type a W here, you're creating a process. When you do ls, and then you are also creating a process. Okay, so anything you do, any activity on operating system, there must be a process associated with that. So actually, a process is an execution of a software, of a program. So if there is no software, and then you cannot log in, right? I cannot do login. You cannot do login. You cannot do ping. Okay, so there must be a process that is running in the operating system. Okay, so I already know what is process. What are the properties of a process? Well, when you run a process, you do ping, Google, blah, 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 blah. Okay, when you do, okay, this command is very, very, very basic skill, ls. Okay, so after you execute, when you execute ls, you are executing a program. Of course, after you execute them successfully, here, okay. So where is the marker? Oh yeah, yeah. Okay, so this is your process, right? So you execute here. Okay, enter, you press enter, and then automatically the operating system will allocate a process. Okay, process ID. Okay, and then here's the result. Okay, blah, 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 blah. And then this is finished. Okay, so how long is your process? So your process start from here to here. Okay, so this is process. Okay. Okay, so when you execute the software or program, well, actually this is a software, right? ls minus l, right? Even though it is a small file, executable file, it's still a process. Okay, when you create a shell script, well, it's a process. Okay, so when you execute the process, so the operating system will allocate resource to the process. What are the resources? For example, CPU allocation, right? Yeah, of course, any process will consume CPU, right? Okay, and then RAM, for example. Okay, so it will allocate an amount of memory for that process. So when you, after you are given an allocation of resources, and then you will have a process ID, okay? After the process is done, and then it's back to the previous state. So for example, this one, you start the process, you get a process ID, and then the process is running. Okay, this is the process. So you process start from here to here, and then finish. So the resources that was already allocated to the process will be put back into the previous state so that other process can use it. Okay, so this process can have a child process. Okay, so a process. So you have a process here, and then there will be another process. Okay, another process. Okay, and then here can have another process. So, and then the process that you are executing here, actually it's a part of other processes. Okay, so yeah, that's how the process works. It looks like a tree. Okay, start from the first. So there must be a process that is start very, very early in the operating system phase. Okay, so this is a process number 1. Okay, process number 1, and then I create another process, and then process, and then process, and then this is your process. Right. Okay. So that's how process works in Unix. Okay. So it looks like a human, you know. So the first human, create another human, and keep going and going and going. Okay, so that's how the process works in Unix. Right, so an example of process, you can execute the command, running a web GUI, you open the browser, it's a process. Okay, so this is another process. Okay, so when you're accessing URL, it's another process. Okay, so there will be a child process, or it can be thread. I will talk about thread later. And then so on and so forth. Okay, so when you stop here, the child will be deleted. So actually, what's the difference between child process and then parent process? So child process is the process that has parents, as simple as that. Both of them are process. And then, of course, there will be a process number 1. Okay. So child means a process that has no child. Okay, so you have a process that runs at the edge, and then this process has no other process after that. So this is called child. This is child. Okay. Of course, the process number 1, it has to be parent, never be a child, right? So it's like a, maybe like a god. Okay, the first process ever in your operating system cycles. Okay, so this process can be child. Okay, so if you see from here, it is a child from here, but from here, it is a parent. Okay, so actually parent and child actually is just a matter of how you see the process. Okay, it's a relative perspective how you see the process. Okay, so a process can be a child or can be a parent. Depends on your perspective how you see the process. Okay, but you get the idea, right? In Unix, you have a process, the first process, and then that process will generate another process, another process, another process, and then these processes are connecting to each other. So there is no process that is independent. No, it's not like that. Okay, so in Unix, all processes are connected, and then they are connected through like a tree. Okay, okay, process, and then yeah, keep going like that. Okay, so that's how process in Unix. Process type, yeah. So when you execute a process, that can be foreground and that can be a background. Okay, foreground and background. So yeah, foreground is default mode when you execute a process. So that will occupy a console. You cannot do anything else because it's in the foreground. But the background, it's different, usually for daemon or service. And then when you execute with ampersand. Okay. So for example, here, okay, make it like this. Yeah, I think it's better. So there is a command named sleep. Sleep 50, for example. Yes, so it means that there is a sleep 50, and it's a process, even though it's a sleeping, yeah. Sleeping means like giving a delay, okay? Why the command is not just rename the command to delay? Well, it's already stayed there for many years, so we just use it. Okay. Well, you'll feel free to add an alias for that. Yeah, it's up to you. It's your own operating system. It's your own computer. You can do whatever you want. So, for example, here you cannot do ls minus l. You cannot do ping 88888. Why? Because this sleep 50. Oh, okay, now it's done. See? So when you do sleep 50, so this is the console. So this is foreground. Okay, foreground. Now, so your command here is delayed, okay, because your foreground is occupied. You cannot do anything else, right? So your command will be executed later. Okay, so that's foreground. Foreground is the default mode, right? Yeah. What about the background? Well, you can do background by putting ampersand here when you execute a command. For example, sleep 50. So it means that you have to wait for 50 seconds until you execute the next command. Okay, sleep 50 ampersand. Off you go. So as you can see, the sleep 50 is located is running in the background. Okay. So yeah, we just wait so that while he's doing sleep 50, we can do anything else. So that's the difference between a foreground and background. So I think by doing this, we are revealing the best feature of Unix operating system, which is multitasking. So in the beginning, when the founder of Unix created Unix, it's already the main ability of Unix is multitask. Uh, I was using computer in 1993. At the time, we were using MS-DOS, MS-DOS 5. Okay, so you have to put the diskette, the big diskette floppy disk. Okay, it's called floppy because it's flexible. You can bend it, you can fold it. It was a very long time ago. And then, yeah, those operating system do not support multitask. Okay, so if you execute one thing, you have to wait for that. You cannot do like so you not like what we do right now, right? Nowadays, operating system is automatically, not automatically, by default, not by default. I mean, it's a standard feature of operating system to be a multitasking. Okay, a long time ago, multitasking only can be achieved in several operating systems, just like Unix, right? Yeah, so that you can see several processes can be done in the same time. Okay, for example, you do a Microsoft Word while listening to an MP3 players, right? So that is called multitasking. And then multitasking is also important in IoT, right? Why? Because you have to accommodate to several sensors. Okay, so you have an IoT device, and then you have a sensor, 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 sensor. Okay, so this sensor has to be independent from others. Okay, sensor number 1, sensor number 2, sensor number 3, sensor number 4, right? So we cannot just wait. Okay, now I'm accessing. Okay, sensor number 1 is done. Okay, number 2, you stop. No, you cannot do it like that. So all sensor needs to be able to send data at the same time, right? So it means that at the same time, there will be several process running at the same time. Okay, so either you can do allocate process here, okay, or you can do threading. Okay, it's one technique to save the resources. Threading is also one feature of an operating system where a process is split it into several sub-process, but it's not child process, okay? Not child process. So there is no additional process when you execute thread able a thread-based process, okay? I'll be talking about thread later. I don't want to make the uh, uh, introduction to be scary. Okay, so that was process. Oh yeah, in several situations we can have a zombie or orphan process. So you have process here, right? And then you have a child process. Sorry, undo. You have another process, okay, another process, another process. Okay. Okay, so this process is related to each other. Oh yeah, one, by the way, to display process, you can do PS, okay. Yeah, Okay. Yeah. So in normal situation, when a child process is killed, the parent process is updated via sick child signal. So we'll be talking about signal later. And then the process can do some other tasks to restart a new child as needed. Okay, so this is, for example, process. This is another process. Okay, so for example, just example. Okay, so you know Apache, right? Apache web server. So Apache web server can be process based, can be thread based. Okay, depends on the configuration. So when you access a web server, Apache, and then Apache will create a process for you. So one process, one connection, one visitor. So this is visitor, visitor, this is visitor, this is visitor, this is visitor. So one visitor, one process, one visitor, one process, one visitor, one process. Okay. So so the purpose for Apache is for web server, right? So when you open a website, you open the page, and then after that you finish. Once you finish, the process will be deleted, and then the resources will be put back into the operating system, right? Okay, so that's how it works. Okay, in normal situation, when this one is done, when you open a website, uh, the Apache will create a process for you. And then when you are finished opening the website, and then the process will be stopped, okay, or will be killed, right? So in not normal, parent process is killed before the child is killed. Okay, so this one is killed, okay? So meaning, okay, let me draw a new one. So in some situations, it happens when you develop C programming, okay, especially based on sockets, you will see this kind of things, okay. So in the beginning, the child is done, okay. So I killed the child, uh, and then the parent process will be updated, and then I will prepare for a new process. But in not normal situations, suddenly the parent is killed for whatever reason, or maybe it's a bug in the process, in the program. So because we have another parent here, right? Okay. So because it's killed for whatever reason, we have process here, we have another process here, but this one is already gone. So this one becomes like this, it's supposed to be, okay? But but it's gonna be like that, okay? So that's why it's called an orphan process, right? Yeah, sometimes it happens. Yeah, sometimes it happens, especially you have a bug here. Okay, so when I wrote the C programming, yeah, when I was studying, it happens. You will see a lot of things like that. So it can create an orphan process, or can done can can generate a zombie process. So zombie is the process is a defunct, so defunction. So this become a zombie. Okay, zombie. Uh, yeah, the process is dead, is not being used. Okay, or orphan process, the complete execution is they have complete execution, but the process is already there. Okay, Yeah, that's how. But that's the difference between zombie and orphan process. Okay, it happens in Unix. Yes, yes. So I have a question. What does the PS stand for? Okay, it's a good question. PS stands for, you can type here, man PS. Actually, PS, cannot see it here. PS report snapshot of a current processes. So PS means process status. Okay, that's the meaning of PS. And it's about what, Bicrotic or not? Sorry, I don't understand here. Fadila Risky. Okay, sorry, I don't understand your questions. Maybe you can rewrite the questions. Okay, so that's the difference between zombie and orphan process. And then we have job. Okay, job. So job is a process. So everything is a process, right? But job is something that is wrapping for another purpose. Okay. Okay. Let me demonstrate here. Okay. So I'll do sleep 500, for example. Oh, sorry. If you want to cancel, you can terminate with Control C. Okay, I'll do sleep 500 and then ampersand. Okay, so you can use FG. Jobs. Yeah, so job means an index or a list, the process that is running in the background. So here, the job is has an index 1. It's like a job ID, for example, job ID number 1. But the process ID is different. Okay, so PS mean, see, CS mean E, for example. E means all. EF. Uh, uh, PS, okay. Is there any, okay. So we have a PS3 here. So as you can see, PS3 display the child process and then the parent process. Yeah, okay. Okay. So as you can see here, it can display, this is the PID. As you can see, this is the PID. And then when you execute sleep, this is the PID. And then when you do PS, just PS here, there was a PID that associated with that PS, okay? So, yeah. So you have, this is your parent, okay? Let me change the color. And then this is the child, and the child is still running, okay? Okay, the child process ID is here, the PS is here, and then the parent is this one, okay? Let's check the job. Is the job still there? Yeah, okay. So job ID So this is the job ID, okay? Job ID, job ID. And then this is the command. The command is this one, okay? And then that command has a PID of this, okay? So yeah, talking about MikroTik is also same. They also, MikroTik actually is the operating system based on Linux kernel. And then they really modified the Linux kernel to their own. So that's why it's really take lots of effort and then time and then energy and then manpower when they release RouterOS version 7. Okay, lots of improvement, lots of yeah, lots of features, new features, and then it's been delayed for many years. I can say years, not months. Yeah, in order to finalize the version 7. But hopefully the version 7 will be much better than what we have now, especially when we talk about the routing engine, routing processing, because they create their own, that's what they say, okay? They create their own routing engine. They don't import from other places. Okay, so that's the difference between process and jobs. Okay, so you have a job ID and then you have a process ID. If you want to put in the foreground, you can use FG %1. Okay, so it means that the sleep 500 will be put in the foreground. You cannot do anything, okay? You cannot do ls because the process is on the foreground, okay? Yeah, in the front of you, okay? Okay, so you cannot do anything, man. Okay, you have to wait. So, is it possible to suspend the process? Yes, yes, it's possible. How to do that? We can use Control Z or Control Z, if British people say it. Okay, we can do Control Z here. So we get our console back. Okay, the ls -l ping, those are gone, cannot be executed because you type them when a program running in the foreground. You cannot execute your own command. You have to wait until the console is free. Okay, so let's check again. But when you see, so previously here, the sleep is running, but now it's stopped. Why? Actually, it's not stopped. It's like a suspend. Okay. So the process is still there. the the uh, the PID is still there. Okay. Okay. The sleep is still there. It's not stopped yet, but they are not running. Okay. Still there, but it's not running. You can see it's stopped. Okay. So how do you start again? Here you can use BG %1. Why %1? Because the index here is 1. Done. Okay, and then you check, and then it's running. Okay. Okay. Yeah, that's the difference between process and jobs. Okay. Next is thread. So thread, you can display a all process, okay, the process that has thread. Hmm. Um, hmm, hmm, hmm. Okay, so maybe it's a capital T here. Yeah, as you can see, wow. Oh yeah, yeah, this is for example. Uh, you can use this command, for example. So PS minus E space minus capital T. So as you can see, this is the first column here is PID. And then this is the sub PID. Okay, so which one when you see the PID? So this is the left column is the one that shows the PID. Okay, so as you can see, same. But when you, this is a process, so it means that it's a process base. Okay, process base. So if you see the PID and then SPID is the same number, and then it's a process base. But when you see here HTTPD is a Apache. Okay, Apache. In CentOS or Red Hat, they call it HTTPD. But in other distribution, they call it Apache. Okay, yeah, just a name things. Okay. Uh, oh, it seems like the HTTPD here is not running. Looks like. Okay, let me check. System CTL. Okay. Uh, looks like it doesn't work. Oh, live practice.glc networks.com. Why? Oh, strange. Yeah. So actually, you should be able to access the live practice, right? Okay, live practice website. You can type in your browser here, for example, uh, live practice, right? Okay, let me open a Firefox. Usually Firefox is much better. Okay, live practice. Oh yeah, here. Yeah, so we run, that's the URL, livepractice.lab.glcnetworks.com. So as you can see, okay, so I'm running HTTPD here. And then this one here is one process, okay? And then one here is one process, okay? So you can see, maybe I can make the font bigger. This one here, okay. 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 So much better. Okay. Let's get back. Let's discuss this one. So, okay, this up to here, it's a process base. Okay. Up to here is the process, but from here to here, so up to there, it's a thread base. Okay. It's a thread based process. Okay. Why? Because this is the thread. Okay, this is the sub process. So from the process point of view, this one only shows one process. Okay, process only one process, which is here. But inside the process, we have small number of sub process. Okay, which is this, 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 and so on and so forth. It's different to the previous one. Okay, so you have a process, and then you have a child process, and then this child process can have sub process. Okay, but here is not. Okay, so that's the difference between process and thread. So how to suspend, I have a question here, how to suspend a process. If the process in the background, you can use Control Z. Okay, so at least you know now what's the difference between the process and thread. Okay, thread is, well, that depends how you design your own software. So if your software is based on process, there will be a process, and then process, a process, process. Okay, and then after you create the process, you create a sub process, and then so on and so forth. And then each process consume resources. Okay, you have resources here, resources here, resources here. Okay, so well, that depends on the application. If they say process is wasting resources like CPU, RAM, especially RAM. Okay, yeah. But with thread, you have a big process, but inside the process you have a small process. Okay, it's called thread. Yeah. Okay. So that's how you you design your own application. It can be thread based or process. Okay. So this called LWP, lightweight process here. So it means the threading, the sub process of a process. Okay. Right. Got it from here. Okay. Next is process management. Yeah, for displaying process, you can use PS. Okay, or you can use top. Okay, top is like a GUI that displays all the processes real time. Okay, so you have a column here. Okay, users, and then if you press spacebar, it will update the table for you. Okay, and as I say, you can see there is a process number 1. Okay, which is the system D. Okay, system D is process number 1. Okay, system D. So that's the origin of process in Unix, in Linux. Actually, it started from CentOS 7 when they use system D. So previously, you have when we talk about init process, there are two ideas about how you manage the process in Unix. First is system V. Okay, system V, and then now they use system D. Okay, The system V is used for Unix, actually FreeBSD is different. FreeBSD use their own init system. System V is as if you use CentOS 6, Red Hat 6, yeah, Red Hat 5. I mean, all process use System V. Debian also System V. But more and more distribution are moved to System D. Okay, why? Because in System D we have dependency. It's why do people invent System D? Because I think previously they saw Solaris management service. So actually Solaris in the beginning they use System V, but later on Solaris use SMF, Service Management Framework, to manage their framework, to manage their service. So this SMF, I think, is become an idea for Unix people to develop their own system like SMF. So with SMF, you have a dependency between processes or services. All right, so yeah, that's how you manage the process. You have a PS. You can use top for displaying. If you want to quit, you just type Q, and then you quit. Yeah, job study, we have done that before. Is there any jobs? Oh, jobs done. Okay, let's do the sleep again. Sleep 500. As you can see, sleep is there. PS, sleep is there. So this is sleep. And then you can send something to, you can send signal to that sleep, okay? Sleep process. Okay, now sending signal between process. So for example, it must be very normal for you when you learn programming. You install first Apache. You have to install inside Apache. You have to install the PHP module, right? After that, you have to install MySQL. Okay, all of them in one uh, one single computer. Okay, so how can the Apache talk to PHP and PHP talk to MySQL? Because they are different process. How come they can communicate? By using Signal. Okay, so that's why we invent Signal. So Signal is a limited form of IPC, inter-process communication. Is used to send data or command between processes. Okay, typically used in Linux. So that's why you can see socket-based. So when you access MySQL, for example, when you install MySQL, you have two options. If you are running on Linux, you have two options. You can access the MySQL using the IP address, okay? Or you can access the MySQL using socket. Okay, so yeah, socket, it's a kind of a form of signal. Okay, so again, signal is created for inter-process communication, okay, or IPC. Okay, for example, there are lots of signal over there. SIG ABRT is this is for signal abort, SIG alarm, signal alarm, signal bus, SIG child, okay, SIG continue, SIG FE, SIG hub, okay. This is the number, okay. SIG illegal, SIG in for interrupt, okay. So when when a sensor wants to send something, they have to send a SIG in, signal interrupt. Okay, SIG hub for hang up, and so on and so forth. So among of this signal, there are SIG SIG kill. Okay, the number is 9. That signal is used to terminate or kill a process that is currently running. Okay, so for example, when I see here it's asleep, okay, I can kill -9. So 9 is a signal number. And then the destination here is the process ID. Okay, this is what I got, killed. Okay, done. So it means that the process here is already killed. Okay, and then when we check the PS process status, and we cannot see them anymore. Okay, another process is signal 15 is for terminate. Okay, let's do it again. But we sent different signal at the now. So previously we sent signal 15, 9, now we send signal 15. Oh, sorry, yeah, I have to check the ID. Signal 15, and then here's the process ID. Okay, and then what is it? It's called terminate. Okay, so as you can see, it's different. When we kill 15, okay, we got terminate. Okay, when we do kill -9, it's called killed. Okay, so it's different signal. So sick, this one is called sick term, and this one sick kill. So both of them are different. This one different signal. Okay. Oh yeah. Sorry, I forgot. It's already 2:30. Okay, guys. So I think we have to stop this webinar. Sorry, I forgot the time. Any more slides? Oh, okay. No, no slides anymore. Preparation is done. Topology. We don't need this. This is not my critique. And then I would like to say that's all. Thank you very much for your attendance. And if you are interested, we have a schedule for training. You can check our schedule on our website. And again, we really thank you for your attention. You're coming here. Tomorrow is a holiday, but you choose to join us in our webinar. Again, thank you very much. We really appreciate your feedback. And then if you don't mind, you can give thumbs up on our channel and like our Facebook page. Okay, any questions, or you have some word from
Yes, please.
admin? Oh yeah, you have question, yes.
Sorry for asking question using voice because I'm using mobile.
Oh yeah, sure.
Okay. There are, let's say, I find word process. Then
Okay.
I find, yes, and then I find the first parent.
Yeah.
When I kill the first parent,
Yeah.
the child process, it must be zombie process or
No. That
kill.
depends. That depends. Okay, so if the parent process killed, and then automatically the child process will be terminated as well. That's what it's supposed to what it's supposed to do in the operating system. But when you write the C code and then you run, sometimes it happens. Okay, you're forking a process, so it means that you will have a child process, and then when the parent is deleted, the child process is still there. That's that, and then that makes us problem. Okay, so the default procedure is when a parent killed, and then all the child process will be gone.
Okay. One
Okay.
more question.
Yeah.
Sorry. I have made okay in the time uh, I saw my disk is full
Yeah.
with the full of the data.
Yeah. You cannot
When
write the data anymore.
yeah,
Yeah.
when I type command df mean h, df
Yeah.
mean sh,
Df minus,
uh,
yeah, df for this free, for
yeah,
checking the this free. Yes.
yes, the disk is already full. But
Yeah.
when
100%.
uh, I checking by du minus h, the capacity of the file or the directory is not the same like in the appear in the df
Yeah.
minus h.
Yeah. It's a good question. Okay. So you need to understand how we save data in the hard disk. So the file size and then the disk size is different. Okay, so you can check when you are using Windows, the total data on the disk and total data of the file itself is different. Why? Because in the hard disk, we use blocking system. Okay, so everything will be put in the sector, even though it's not fully 100% utilized. So for example, you have a block of 1 MB. Okay, so your hard disk is using 1 MB blocks for storing the data. It means that if you just only have one file that has size of 100 kilobytes, so it means that it will take up 1 MB block. Okay, do you understand? So it means that when you see the disk usage, you will see 1 MB is already been used.
Okay, okay.
Understand?
Yes, understand. But
Okay.
in the time, because I don't know what happened, I
Uh-huh.
just deleted some big size of file.
Oh yeah.
The
Uh-huh.
file is already deleted. The command like rm mean r, the
Yeah.
file is already done, but the size of the disk is not not decreased,
Well,
not decreased. Yes, not the decrease. When I type command ps out, I
yes.
still I still see the list of the command r m, the r, the file.
Yeah.
When I kill that command, the
Uh-huh.
disk size is become bigger. What actually happened?
Maybe something wrong with the process over there. I'm not sure because I cannot see the operating system lively. Sorry.
Mm,
Yeah.
yeah,
So
yeah.
yeah, it happens when you. Yeah, I mean, I wrote C programming, C programs based on Linux, and then at the time uh, we were given a task to set up a a software that is running on that must open a socket so that other hosts can access it. So it's like client server software. Okay, and then sometime it happens. Okay, uh, but regarding with the files, it looks like there is a log file that is still running on the that is still writing files on the disk. So it seems like, so you need to find the process that is really writes the disk, and if you are able to kill, and then you can kill the process. So thing is, you need to find out which process that is doing the task.
Okay,
Okay.
understand, understand. Yes, understand. Thank you very much.
Okay. Yeah. So I cannot give you more details information because it's very, very technical. I need to check the operating system directly. Right, guys, thank you very much for the questions. And now it's already 20:48. Okay, we're supposed to stop many minutes ago. Again, thank you very much for your attention. And we really like your feedback to make our webinar better. If you
Yes.
have any suggestion for topics, you can write them in the feedbacks. Any comment from admin?
Yes, okay. Thank you very much for your attendance. We hope this webinar will give you a good benefit as well. So happy holiday, happy, stay safe, stay healthy. And the last request, please turn on your video. We can take picture together.
Oh yeah, it's
Yeah, this is like
picture
a
time. Okay, right.
picture time, please.
Okay, can you see?
I can't see. Many of you, please.
Hi, admin. Can you see admin?
Yeah, please.
All right. Okay, turn on your what is it? The camera.
Yeah, don't be shy, please.
Okay, say 1, 2, 3.
Smile.
Smile. All right. 1, 2, 3. Smile. Okay. So I think that's all, admin. Anything else?
Yeah, just that. But see you next Thursday. So please fill up the form for the feedback. So this is really important to us.
And then yeah, see you next week then.
Yeah,
Okay,
see you
so
next day. So happy holiday.
right, thank you very much, admin. So right now I'll be turning off my microphone, and then for those who are still writing down the feedback, we'll still keep the webinar live after you're done, and then you can leave. Again, thank you very much for coming. See you later.